This is the second video I have for section 13.5, and the learning outcome is use your understanding of the primary immune response, the secondary immune response, and memory cells to explain why vaccines work. So this is described in your book, and this table comes right out of your book. There's more detail here with IgG and IgM antibodies, and we're not going to really talk about that. I'm just going to look at like the total antibodies and how they respond. So we want to talk about just getting exposed to a pathogen for the first time. So in the case of active immunity, where you're getting exposed to a pathogen and you're making your own antibodies, here's what they're showing you here. This is the antibody titer, the concentration of antibodies in someone's blood. And here's time. The x-axis is time, y-axis is concentration of antibodies. What happens is a person gets exposed to an antigen. Let's say you got exposed to a cold virus. And this is the first time that your body ever saw that cold virus. What happens, and that can happen because there's lots of different cold viruses. But anyway, you get exposed to that cold virus, and there's this latent period, this kind of period where you're not increasing the amount of antibodies, but your body is getting ready to make those antibodies. So it takes a little bit of time. Here they're saying the plasma cells, which are a certain kind of B cells, are going to start, they've got to, first you got to start making more of these B lymphocytes, and then some of those become plasma cells and they start making antibodies. So a lot's got to happen before the antibodies actually get produced. So you have this little bit of a lag period, and it just depends how long is that. It just depends on the pathogen. It depends on your immune system, how much you've gotten exposed to, that kind of thing. But probably, a couple of days, maybe a week at the most. But so you have this little latent period, and then your body starts to make antibodies, and your concentration of antibodies starts to go up, and it gets to a peak, and eventually that concentration will go down. What happens, we call this the primary immune response. The amount of antibodies, or the pattern of the antibodies that you make the first time your body's exposed to a new antigen. Primary immune response, the amount of the pattern of antibody production the first time your body's exposed to a new pathogen. So what happens here is we've got this little lag period. And the other thing you might notice is this concentration of antibodies is not very high compared to the secondary immune response. So you're more likely to get sick from this pathogen the first time your body's exposed to this antigen. You're more likely to get sick from a pathogen the very first time your body's exposed to a new pathogen. And that's because you've got this latent period. You've got this period you've been exposed to this antigen or exposed to this pathogen, but your body's not making antibodies yet. It's not protecting you yet. And so you might get sick during that period. But eventually your body does start to make antibodies. You do start fighting off this pathogen, and you usually get better. So primary immune response isn't as great as the secondary immune response, but most of the time you are going to improve and get better from this. The big important thing about the primary immune response is that you've made antibodies, and that's really good. Your body's made antibodies to fight off the pathogen. But the other thing that those B lymphocytes are making is they're making memory cells, and that's here. So memory cells are a certain kind of B lymphocyte that can last in the blood in sometimes up to decades. So when we look at antibodies themselves, antibodies only last a couple weeks. And again, that can vary depending on your body, your immune response, the kind of pathogen and whatnot. But antibodies typically only last a couple weeks. When you have this primary immune response and you're making antibodies, you're also making memory cells. certain kind of B lymphocytes that can last in the blood for up to decades. And it's those memory cells that allow us to have a secondary response. So here a time period passes. And, whatever, it could be a couple months, it could be a year, it could be 10 years, whatever. But you have these memory cells floating around in your bloodstream. And these memory cells look just like all the other B lymphocytes, except they can only make antibodies against this original antigen. So that original cold virus that you got. So now you're exposed to that same cold virus. And at this point, 10 years later, and what happens? Those memory cells, there's a lot of them there. They've done this before. They're going to start making antibodies, and they're going to do it very quickly because they no longer need this lag. They already have the instructions on how to make the antibodies against that virus. And so they're going to make antibodies against the virus, and they're going to make a lot of it, and they're going to do it quickly, which means you're not likely to get sick a second time because your immune response happens very quickly and at a high level of antibodies. And we call that the secondary immune response. The secondary immune response occurs the subsequent time or times that you're exposed to the same antigen. Because you have memory cells, which are a certain kind of B lymphocyte or B cell, you can make antibodies quickly and at a high concentration and fight off that pathogen before it makes you sick. This is why most of us only get things like chickenpox once. But then you're saying, wait a minute, you're talking about cold virus. We get colds all the time. But it turns out there's more than 200 different kinds of viruses that cause colds. And those viruses can change a lot. They can mutate a lot. So you might not have gotten the same cold twice, but you've gotten a lot of different colds many different times. So we've got all sorts of memory B cells floating around in our blood system for all different cold viruses. Okay, so we get the primary immune response and the secondary immune response. And so this is not in your book, but I think it's a good just a reminder to say, so how does that immune response connect with vaccines? Well, here's what we're describing from the previous, if you look at that graph and you're exposed to a pathogen. And so there's the person exposed to the pathogen, and they're going to make all sorts of antibodies and memory cells. And the first time you're exposed to it, lots of things can happen. They can get sick and they can recover. If it's a dangerous pathogen, they might get sick and die. Or they might get sick and have a disability. So it might be something, you get long COVID or something like that. But if the person recovers, they're going to have this immune memory. They're going to have those memory cells. We can mimic this process by using vaccines. So instead of exposing the person to the actual living infectious virus, we can expose them to a vaccine. And we're going to talk about that in a minute. And the vaccine is also going to give that person an immune response. But they're not going to die or be disabled. They're going to be fine. They're going to get vaccinated. They're not going to get the illness. They're going to be fine, but they have the benefit of that primary immune response because the vaccine caused them to make these memory cells. So the bottom line, I'm going to go back to the graph on the previous page. The bottom line is a vaccine can give a person the primary immune response. The vaccine can cause this primary immune response to occur without the patient getting sick, but with the production of memory cells. Got it? Okay, so vaccine, no getting sick, no feeling lousy, but you do make memory cells. I think I'll stop right there and we'll go on to the next topic in another video.